There are two kinds of friction. Cicarelli, what are they?
Static friction and kinetic friction.
What is the difference between static and kinetic friction, Cicarelli?
Static is when it's not moving, and kinetic is when it's in motion.
Friction, general equation for friction. Look. It actually works out to be two different equations in the end, but what is the general equation for friction? Something with mu. Yes, Bob.
Force of friction equals the coefficient of static or kinetic friction times the force normal.
The force of friction equals mu times force normal. So this mu here, which is like a U with the tail at the front, is the Greek letter mu. It's a great Scrabble word. Just so you know, nu is also a good Scrabble word. Like when you're trying to never mind. Okay, so mu, and this is called the coefficient of friction. The coefficient of friction, of course, is dependent on what materials you're talking about, whatever surfaces they have, and it's really an experimentally determined thing. So the coefficient of friction, and if you'll look, the force is going to be in newtons and the force is going to be in newtons, so the coefficient of friction actually has no dimensions. So please make sure you're aware of that. It's dimensionless. And let's see. So we can have the force of friction is equal to mu times the force normal. Actually works out to be several different equations, which is to say the force of kinetic friction is equal to the coefficient of kinetic friction times the force normal. We can just substitute in kinetic friction. But static friction doesn't quite work that way. The force of static friction is less than or equal to mu s times the force normal. This means that the maximum force of static friction, and this is actually slightly redundant, is equal to mu s times the force normal. You should be able to see that from this equation, that the maximum would be equal to mu s times the force normal. And just to take a brief moment and talk about what that means, that the force of static friction is actually less than or equal to the force, the mu s times the force normal. Let's just take a moment and look at a simple situation. We have our dictionary. We're going to draw our first free body diagram today. Don't you worry, we will draw many more through the course of this class. Hedler, free body diagram on the dictionary right now.
There is a force downward, which is the force of gravity.
And
there is a force upward, which is the force normal.
what leads us to believe that the force normal is upward at this time, Sydney?
Because it's the surface is on the book, and also the book's not moving, and the force of gravity exists.
What's interesting is you have yet to use any of the terms for the force normal in your description of the direction of it. I understand at this point that that's pretty obvious, the direction, but using what normal means and the various things to describe the direction of the force normal.
So it's perpendicular to the surface.
Number one is perpendicular to the surface, which means it's either up or down,
And it's a push.
which means
So it's up.
it has to be up. Great. So this is our free body diagram. I'm going to alter our free body diagram slightly. Switch hands. Make it easier. Woo! Jessica, how do I change free body diagram?
There's a force applied going to the right.
There is a force applied going to the right and
What is it called?
something prevented it from moving, true? What prevented it from moving? Friction, so this is?
Force friction.
Force of friction. I'm not going to identify which kind. We'll talk about it in a minute. Okay, so let's talk about this piece. You knew, actually, in that particular case, that was the force of what kind of friction class? Static friction. Okay, so that was, it wasn't moving, so it was force of static friction. So let's say, when I apply a force of 4 newtons. No, let's not do that. Let's do it this way. So let's say that the maximum force of static friction is 4 newtons. Okay? Maximum force of static friction is 4 newtons. If I apply a force of 1 newton, What is now the force of static friction? Class. 1 Newton. Okay, if I increase it to 2 newtons, it's not, the force of static friction is now. If I change the force I apply to 3.9 newtons, the force of static friction is now. Good. If I increase the force of static friction to if I increase the force applied to 4.1 newtons, the force of static friction is now. It doesn't exist because it's going to start to move. Okay, that's what the force of static friction does. It adjusts. It changes to keep the object from moving. Once you exceed the ability for the force of static friction to keep the object from moving, the object will start to move and it will switch to kinetic friction. Great. In general, we know a relationship between the coefficient of static friction and the coefficient of kinetic friction, with the exception of Teflon, which acts more like a liquid than it does a solid. What is the relationship between the coefficient of static friction and the coefficient of kinetic friction?
Coefficient of static friction is greater than the coefficient of kinetic friction.
In other words, it is harder to get something moving than it is to keep it moving, because the coefficient of kinetic friction is greater than the coefficient of static friction. We are going to draw free body diagrams.